Hey, hello everyone. Good evening. Good evening. Kalpit has joined, Stuti has joined, Jaijit and Nehal. Can you quickly give me the confirmation that the voice is clearly audible? Can you confirm the audio is clear? Is my audio clear? Good evening, Stuti. Good evening, Kalpit. Audio is clear. Great. All right. All right. Okay. So let's get started, right? So as we know the agenda, so I'm hoping that some of you have followed me on the uh, right, you have followed me on YouTube, so where we were doing certain basics of time speed distance. The first three lessons were very important, so time speed distance 1 2 3, and then we are getting into the application side of it, right? So one, we did the applications with respect to trains, and today we'll be doing on escalators, right? Similarly, tomorrow we'll pick up on boats. Likewise, we'll quickly pick up the different applications, then we will start from the base and we'll quickly reach the cat kind of level. What is the kind of questions there, and we will stop. That has been the nature of every single lesson that I do, right? So we start from the base, so especially on the quant, and then we will build it to the cat level. So in the single topic, we will, with respect to that agenda, we will move from one area to the other area. So generally I am there on the YouTube, or be it on the SE at 2 p.m. and 10 p.m. These are the preferred timings. I would be generally there between 2 and 10. At 2 generally I do LRDI in the afternoons, and in the night we continue our journey with quant. So that's kind of, we'll fix it. Let's see if it is required, we will change this on some stage. But for now, that's most comfortable, and this is the pattern that I'm following. Uh, all right, so let me quickly introduce. Oops, okay, it's a very different interface. Yeah. Hmm. That's a little bit about me. So those who are following me would know about it. In case anybody is new here, Shadow has joined. Shadow looks like new to me. This name I never heard. Okay, any which way. So if you are following me here, so I have worked with various test prep industries. I'm not sure how well the font is visible, my friends. So I will try my best to put it to perspective. Yeah. Okay. So I worked with various test prep industries like Time, Endeavor, and Career Launcher in the past for about 14 years. And I have also developed expertise in training both the trainers as well as the students in the areas of quant, LR, and GI. And I consistently scored 99 plus percentile and missed 100 percentile, but small margins here and there. That's about me at the background. And okay, so if you want to speak to me, probably you can follow this Telegram group out here. I mean, it's I don't. So this is the generic group, but then you can tag me out there and you can speak to me. There's a little different interface to me. I'm kind of a bit struggling to understand how this interface is working. It won't be a problem as we go along. But at the beginning, it's a, I might take a couple of minutes to understand this particular interface from my perspective. I used various different interfaces in the past with respect to technology. So every technology has its own nuances. So it'll take a couple of minutes by the time I kind of adjust to this, right? Yeah. Okay. So here we go. This is the kind of the background that I would like to put it. So let's come straight to the topic, which is escalators. Let's start out there. A couple of things that you might have to know when it comes to escalators. Number one, so if there is a font, there is a problem there, just let me know. All right. Yeah. Nehal, what is that you're trying to say? Today DLR class was not there. Yeah, because they forgot to schedule my class. Right. So somewhere there was a technical problem. Yeah, pretty technical problem, and hence there was an issue. Otherwise, I scheduled one at 2, one at 6, and one at 10. In fact, I wanted to do 3 lectures, but by the time that was sorted, it was almost late in the evening. So I thought I will therefore take only the night lecture. Right? That's a question that you asked, why there was no LRDI. All good, but then except the technology did not feasible. It did not support me, in fact. Fair enough. Let's get started. Three things to know, understand about the escalators. First, number one, Number of visible steps are constant. Assume that you are at the ground floor. Let's assume that you are on the ground. This is ground, let's assume. From here, the number of visible steps I'm talking about, right? I'm talking about the number of visible steps. All right, someone wants to go here. Say this is the topmost point and this is the bottommost point. Whether it's a staircase or whether it's an escalator, it is pretty much visible, right? So this the number of visible steps are constant, except that if you're on an escalator, if the moment you stand here, this particular steps keep moving. That is it. That is the only stuff here. If you are standing here, you are here, and if standing here, this particular steps keep moving. It goes up, then it goes up, it goes up. Nothing but you are moving up, in the sense the step on which you are standing is moving. There is a belt behind that, right? There is a belt which is trying to move this particular escalator. Other than that, I don't find all it now it is any different out here, right? So therefore it's a moving escalator. One thing what is constant, first understand that, just like we said, distance constant. Those who are following me from the first lecture on time, speed, distance, now this comes down to the concept of distance is constant. It boils down to that. Oh, is it so? Which is the distance which is constant? The point, the distance between these 2 points. But we talk distance in terms of steps in this lecture. In this particular lecture, we talk distance in terms of steps. That is the only difference there. Number of visible steps are constant. Point number one. This should be very clearly drilled in your mind. Number of visible steps. Number of visible steps are constant. Nothing but distance constant. If you ask me, sir, under which category this problem belongs to, distance constant problem. In the very first lecture, we spoke about distance constant is very, very important. We said this is also distance constant, right? Yeah, number of visible steps are constant. Point number one. All right, point number one. Point number two. Point number two. So second point that we define is effective speed, not relative speed, my friend. I call it here as effective speed or resultant speed, whichever way. All right, good to call it as effective speed or resultant speed. Don't call relative speed, because what comes to your mind the moment you say relative speed? If two bodies are moving in the opposite direction, you say that add the speeds, right? Now, therefore, add the speeds. If two bodies are moving in the same direction, the relative speed is subtract the speeds. But that's not the case here, because if you are standing on the escalator and if you start walking along with the escalator, for example, you started moving, you also wanted to walk, and escalator is also moving. Therefore, what is happening? Resultant speed. In the sense, in effective speed, what happens is if the escalator is moving up and you also decide to take some steps, right? The effective speed in this case, you are also trying to move up and the escalator is also trying to move up. Effective speed will be the speed of escalator. Let me write it as E. Throughout this particular lesson, effective speed of the speed of the escalator, we will take it as E there. Person speed will keep changing. Based on the name, we can keep changing. Let's, for the time being, let's understand that the speed of the person is yes. Therefore, if the person as well as escalator are moving in the same speed, the effective speed would be higher. This is precisely the concept you use in boats and streams, right? If the boat is moving along with the water, you add the speeds, which becomes the effective speed there, right? Not the result. It's not the relative speed. We rather call it as effective speed, because relative speed can confuse us sometimes. Okay, that is the effective speed. What if somebody wants to go against the escalator? So you might not have seen, because it may not be very practical. Nobody dares generally to go against the flow of the escalator. But what if that is true? In a sense, escalator is trying to move up and the person is trying to come down. Person is trying to come down and finally somehow he reaches down. Let's assume that. So in that case, what happens? The effective speed in this case will be speed of the person minus speed of the escalator. You may say that, sir, why not escalator minus speed of the person? Then the person will not go anywhere. If the speed of the escalator is better than the speed of the person, then the person will be here itself. He will not be able to get down. So naturally, the speed of the person has to be better than speed of escalator. Therefore, you say that, all right, S minus E. That is what you kind of talk about there. Fair enough. So now, second point. What is the second point I'm trying to say? Effective speed. Let's pay attention to effective speed. One, number of visible steps are constant. Nothing but it comes under the category of distance constant. Number two, effective speed. All right, we talk about the effective speed. If both person and the escalator are moving in the same direction, we add the speeds. If the person and escalator are moving in the opposite direction, we subtract the speeds, right? So we kind of take the difference between the speeds. Number three, speed is defined in terms of, which means F is defined in terms of steps per unit time, number of steps taken per unit time. All right, you may say that. Can I say that X steps per second, per minute, right? Per, whether you want to write per second, you want to write, or per minute you want to write, doesn't really matter. So which way you want to write it, right? So all it matters is speed is defined in terms of steps per second. We will write the speed in terms of steps per second. These are the only three things. So all back to whatever we did before, just that we introduced another new word today called as effective speed, which is pretty easy to understand to everyone. Now let's go to problem solving. That's all the basics is. Number one, first and foremost thing is number of visible steps are constant. If we don't understand, then nothing we can do about it. It's not infinite number of steps. No, number of visible steps. If you stop the escalator, if the switch off the power, the number of visible steps are constant. If you stand there, you'll be climbing actually those many steps, right? Technically. So therefore, number of visible steps are constant. Point number one. The effective speed, the point number two, and the speed is defined in terms of steps per unit time, right? We will not talk about meters per second or kilometers per hour. Rather, we talk about steps per unit time. Let's go to one of the simple example. Let us build, and then we will attack the cat question, right? So first, let's build some concept. Then we will take a couple of questions which appeared in cat. Let's take a look at this. Let's go to the next. Let's go to question application. Let's now try to go on to the application. All right. Right. Okay. Do it with me. Read alongside me. Harry walks up on a moving up escalator, which connects which connects ground floor with the rooftop. All right, it directly goes to the rooftop via, which means it doesn't go through first floor, second floor, etc. I assume that this escalator is outside. All right, it disconnects ground floor with the rooftop with a speed of 1 step per second, and hence takes 50 steps to reach the rooftop. Now look at this. This guy wants to walk along. He doesn't want the escalator. He doesn't want to stand on the escalator. Looks like a little bit of in the sense of hurry. So therefore, he wants to go up. All right. So therefore, he also keeps walking. He takes 50 steps, fair enough, to reach the rooftop. He turns around and runs down the same moving up escalator. Looks solid. Now this looks pretty adventurous. This guy looks very adventurous. Same moving up escalator. Probably he can go down the moving down escalator, but he decided no, there is a moving up escalator, but he decided to run down that escalator with a speed of 5 steps per second. That's pretty speed. 5 steps per second is too high. 5 steps per second, but he counts every time he takes a step. He counts. He's counting that there are 125 steps he has taken. Therefore, the question is find the number of steps to be taken by the Harry to reach the rooftop from the ground if the escalator is switched off. Right. So that's what we are talking about. Fair enough. Let's take a look at this. Let's understand. So what is happening therefore? Firstly, let's understand the first statement. Let's go to the first statement. First, let's go to the first statement. At the rate of 1 step per second, to go 50 steps, the time taken. Couple of things. Listen to me, guys. Listen to me. Okay, listen to me very carefully on the first question. After this, next 3 hours, by the time we go to the third or fourth question, you become very, very comfortable. First of all, what is the speed of the person? Speed of Harry. Speed of Harry is 1 step per second. Speed of Harry is 1 step per second. I will write ST per S. Speed of Harry is 1 step per second. Okay. What is the speed of escalator? Speed of escalator. Speed of escalator is E steps per second. Let's say E steps per second. While going, escalator and Harry moved in the same direction. Therefore, what is the effective speed? What is the effective speed? Effective speed of these two characters. So effective speed is 1 plus E. All right, 1 plus E is the effective speed. How long did they run? Now I'm coming to the time taken. Time taken. How long did they run here? All right, they ran for 50 seconds. In the sense, for 50 seconds, because to go 50 steps at the rate of 1 step per second, he counted how many steps he has taken. To take 50 steps at the rate of 1 step per second, he wants 50 seconds. So therefore, time taken is 50 seconds. In the sense, in this 50 seconds, escalator was active as well as Harry was also active. Both were active for these 50 seconds. Technically, both of them were active for these particular 50 seconds. Fair enough. So multiply them. So we'll get the number of visible steps. This is equal to what? N. What is this N? Total number of visible steps. I will write it as N here. Okay. Second point. Coming to the second point. Second statement. What has happened in the second statement? He's saying that Harry moved down with 5 steps per second. All right. He moved down with 5 steps per second. 5 steps per second. Harry moved down with 5 steps per second. Just a second. Should I be changing the slide background? Hmm. Any which ways, let's carry on. Yeah. Hmm. Okay. Right. 5 steps per second. So if you look at the other person here, so if you look at the escalator will be doing e steps per second. What is the therefore effective speed here? The effective speed is 5 minus e. The effective speed becomes 5 minus e. How long did they travel? Coming here. Now look at this. He has taken 125 steps. This guy has taken 125 steps at the rate of 5 steps per second. I will get the time here. 125 steps at the rate of 5 steps per second. 25 seconds. Therefore, this man has ran for 25 seconds into 25. So what this will be equal to? This also will be equal to number of visible steps because he has to come down the same number of steps to reach the bottom. He has to climb up the same number of steps because if you stop the escalator, the number of steps will remain constant. Let's understand this. Number of steps will remain constant. Therefore, so that also will be equal to the same distance because distance between the floors is same. Why did they put all this effort? All this effort is to come down. So why did therefore n is this n is constant here? So equate both of them and solve. Therefore, you will say that 1 plus e times of 50, 1 plus e times of 50 is also equal to 5 minus e times of 25. 25 one time, 25 two times, resolve them, you get 2 plus 2e is also equal to 5 minus e. When I resolve it, you will understand that 3e is equal to 3, therefore e is equal to 1. So therefore, escalator was taking 1 step per second. Now his question is, hey, how many steps are there between these two, between these two places? Simple number of steps. All right, we'll come to it. So take one of these equations and figure out how many steps are there. In place of e, put 1. Therefore, 1 plus 1 becomes 2. This bracket value becomes 2. 2 into 50, which is equal to 100. You may say that, sir, can I find from the second one? Of course, you can find the second one because number of steps will be same. That nothing but the distance between the ground floor and the first floor or the top rooftop and the ground floor is the same. Distance will not change. Distance is nothing but number of visible steps. As much as you understand that the distance is constant, we are sorted. All right, distance is constant. That is, distance between any two floors is constant. Nothing but number of visible steps are constant. Pretty simple question. Allow me to do one more. By the time I do one more, all right, you will be able to understand it better. Allow me to do one more here. So we'll be able to understand it a lot better. Yeah. Okay, before I quickly go on to the next slide, let me do a quick announcement on this. Quick announcement on this. There are two types of subscriptions, as you all know. One is the plus subscription, the other one is the iconic subscription. See, all that one thing that I believe in, I'm not saying that, okay, you must buy this, that, that's not the whole idea. One thing I would like to say is do always a structured course, guys. Do always a structured course. Otherwise, getting result is a challenging. For example, what some people do is hip hop. They will see something here and there that will not help. From where you do doesn't matter. Do certain structured learning. That's very important. Even if you look at my classes, I do it in a very structured way. I take from here to there. Likewise, everything has to be learned. For example, if you are learning swimming, you can't say that I just visit swimming pool one day, next day I will go and do some cycling, or next day I will go and next day I will go and try some car driving. No, all it's structured way. Learn properly. In the sense, if you want to learn an RC, follow the course on RC, right? 10 lectures, 15 lectures, 20 lectures, very systematically follow. That is when skills develop. 15 days, 20 days, you go to the swimming pool for the skills to develop. hip hop here and there, doing this, jumping here and there. It will not develop any skill. Now, who can do such things? Master of the subject can do such things. Somebody is very good in RC already. Somebody knows their quant fundamentals very well. So now they are looking here and there for some approaches, value addition. Then hip hop will help. No, I'm learning, which means somebody who knows the swimming, somebody who knows cycling, somebody who knows car driving. Can that fellow do everything? Yeah, on the same day in the given 1 hour time. Yeah, do a little bit of swimming, come out, do a little bit of driving, do a little bit of cycling, because you know all of this. So provided when you want to learn some cycling, stay focused. Stay focused. Otherwise, you will not learn cycling, right? So that's very important. Structure. There is a program, right? So that's what the plus technically does. Well, it technically does. Also, so that if you look at the iconic, so you will get the personal guidance. Some of all at times, if you know the personal guidance, yes, speak to somebody that is worth it. That's worth it. So study planner. Some of you would be, some of you does, some of you want to understand the study plan. Probably study plans would help. Things like that. All right. Now, therefore, it has its own pluses and minuses. You are all smart enough to understand this. All right. Yeah. Coming to the, if you were to understand the subscription fee on this is how it kind of looks like. Right, so you use Belvi 100, that is the code. Use Belvi 100. If you use Belvi 100, you will get 100% discount. No, you will get 10% discount on whatever the subscriptions that you are trying to look at. Fair enough. Continue to the lecture. Back to the lecture. Get back to the lecture. Okay, Nitin is walking up an ascending escalator. Do it with me. This question, you do it with me. After this, your concepts will kind of get drilled. Yeah, Nitin is walking up an ascending escalator, which connects ground floor to the rooftop restaurant. He finds that to reach the rooftop in 30 seconds, he has to take 45 steps. And to reach the rooftop in 24 seconds, he has to take 72 steps. How long would the escalator take to bring him from ground floor to the rooftop if he stands still on the escalator? First let's come to it. Two cases are given. You may wonder that, sir, every time why we are getting two cases. First question also had two cases. Second question also has two cases, because there are two variables, right? There are two variables in the equation. Number of visible steps is a variable. Escalator speed is a variable. Generally, if you understand the last question and the previous question, two equations are required because there are two variables involved in this game. Simple. It's as simple as that. Okay, coming back to this, let's understand here. Nitin is walking up an ascending escalator, which means escalator is moving up. Escalator is moving up, which connects ground floor to the rooftop restaurant. He finds that to reach the rooftop in 36 seconds, this is the time, my friends, he has taken 45 steps. Therefore, case one. All right, in the case one, do I know the speed of Nitin? Yes, speed of Nitin, I know. He has taken 45 steps. He has taken 45 steps in 36 seconds. In 36 seconds. Say, what is the speed of the escalator? Speed of the escalator will be E itself. Hey, what is the time taken in this particular journey? The time taken is 36 seconds. In the sense, 36 seconds escalator was active. The Nitin was also active. Both of them were active for 36 seconds. Both of them were active. Fair enough. Since both of them are moving in the same direction, what is the effective speed? I would add them up. The effective speed into time taken will be equal to what? Number of visible steps. Done. Over. First premise is done. Let's come to the second premise. And to reach the rooftop in 24 seconds. Now, second premise, 24 seconds. If he were to reach, but he's changing his goal. First 36 seconds, he said. Now he said that in 24 seconds, I want to reach there. Then he ended up taking 72 steps. Very good. Therefore, in the second case, what is the speed of this particular person? Number taken 72 steps. He has taken 72 steps in how much time? In 24 seconds time. This becomes the speed of Nitin. Okay, and then escalator. Escalator speed remains C. Why did I add? Because again, he's going in the same direction, right? Only the goal has changed. That's it. He's going in the same direction. Only the goal has changed, right? Goal has changed. Otherwise, he's moving in the same direction. Fair enough. Right, which is all. How long did they take? 24 seconds. On the entire 24-second, escalator was also moving. Nitin was also moving. 24 seconds is equal to what? Is equal to number of visible steps. What I need to do, just got to solve it. If you solve it, you will get the value of E first. From the value of E, you can find out whatever you want on this particular question. Fair enough. Let's solve it. Therefore, let's solve it. So I'm simplifying. I'm equating the first equation with the second equation. So I'm simplifying it as well. Simultaneously, I'm simplifying it. All right, I'm simplifying it simultaneously. In the sense, 45 by 36 here. 45 by 36, I'm writing it as 9 5 times. 9 4 times plus E into 30 into 36 is also equal to, why it is equal to, both of them is the distance is constant, therefore I'm adding them. I will also write it as 72 by 24. This by this is nothing but 3 plus E times of 24. I would solve from here. I will get the value of E from here, right? This is 12 two times. This would become 12 three times. Let's simplify this. 15 divided by 4 plus 3E is also equal to 6 plus 2E. Therefore, from here you say that E is nothing but 6 minus 15 divided by 4, right, which is nothing but 9 divided by 4. That is the speed of the escalator. Once I get the speed of the escalator, what do? Go back, substitute in this. You will get the effective speed multiplied by t. Or you will get the n value required there. Or you can substitute in the second equation also. Anywhere it is fine. Shall I do it in the second equation? Let's do it. Therefore, you say that, hey, this is nothing but 3 plus, what is the value of E? The value of E is 9 by 4. Let me add that. 9 by 4 times of 24, which is also is nothing but number of visible steps. Simplify this, you get this as 72 plus 6 into 9, 54, which is equal to number of visible steps. All right, so what did we get here? Number of visible steps is what we got here. Now what he wants, therefore, how long would the escalator take to bring him from the ground floor to the rooftop? Bring him from the rooftop if he stands still. Fair enough. So I know the number of visible steps. How many visible steps are there? 126 steps. What is the speed at which he is moved? The escalator would move 9 by 4. 9 by 4. All right, that is the speed with which the escalator moves, right? Yeah, let's cancel this. Therefore, 9 one time, 9 four times, therefore 14 into 4, right? Which is nothing but 56 seconds, which is the answer. Okay, at this stage, give me the quick confirmation that you understood the fundamental. You understood the fundamental three things. All right, number one, the distance is nothing but the number of visible steps, distance constant. The effective speed is number two, right? Effective speed, if they're moving in the same direction, add them. The effective speed. Number three, the speed has to be measured in terms of steps per second. Yeah. So is this clear to you? Is this clear? Kristen, you are asking that is there any shortcut? Why shortcut for this? When do we need a shortcut if the question is really, really cumbersome? It's a distance constant. Concept is distance constant. Time and speed are inversely proportional. Right. So what do you do? No, you only tell me if there is anything to be done. You look at all these numbers, 36, you look 45, you look at all these numbers. Numbers keep changing, but this is all the concept is. So I don't want to write these two cases once you grow up, which means once you understand it. All we do here is we write this equation directly. That's it. All right, we end up writing this equation directly. This is to teach. I'm saying that there are two equations coming out there. Idea is what? Number of visible steps is constant, distance is constant. Equate, directly equate. This becomes your starting point. Clear, Kristen? That becomes your starting point. These two steps are not required here. Do start there and solve it. That's it. Write this equation directly and resolve. You are done, sorted. Made sense? Yeah. So okay, now this is the baby steps to start with, but doesn't mean that okay we need it every time. You have to refine it. You can't see, that's another thing, right? You don't write as much as I write, right? Even if I'm writing the exam, I will not write as much as I write here. So I don't write case one, I don't write case two. We will not write. Neither I write nor you write, because there are no steps for marks. There is step only for the final answer. Marks are only for the final answer. There are no steps. But yeah, while teaching, I have to write it only, then the concepts get cemented. I cannot skip those steps. Okay. Yeah. So therefore, while writing, it appears little higher. But reality is not as high as what we talk about here. Right. Good. Let's move to the next one now. Let's move to the next one. How much is visible in like a font of this size? Is this visible? How much zoom I should do? I will do a little bit of zoom, understand. All right, now is this fine? Is this fine? If you're watching on the laptop, I think this should be pretty fine. If you're on the mobile, I'm not sure. Stuti says this is enough. Anybody else? Should I increase the font or is this making sense? This font is visible. Yes, no. Is this font fine? Anybody else? Quickly confirm. Is this font fine here? Fine. Shadow also says. Shadow, what is your name, by the way? Shadow is a nice nickname, no doubt. Gaurav, all right. Okay. Yeah. Fine. All right. Let's take a look at this. Two questions, right? Data is same. We have two questions based on the same data. Data remains same. Let's take a look. An escalator is moving from first floor to the ground floor in a shopping mall. Nicole took 30 seconds to reach the ground floor when she took 25 steps. But if she tripled her speed, she would take only 18 seconds to reach the ground floor. So, as already now the Kristen was saying, let's try and write it in one sentence because we know that the distance is constant. How does my first sentence would look like? So, the she's first already so from first floor to the ground floor in a shopping mall. Nicole took 30 seconds. That's the time to reach the ground floor when she took 25 steps. All right, now listen to that. Kristen, all right, now Nicole's speed. Nicole's speed is 25 divided by 30. That is the speed of the Nicole because Nicole has taken 25 steps in 30 seconds. All right, this is the initial case. This is the speed of Nicole. And I will add the speed of escalator to this. I will add the speed of escalator to this. Speed of Nicole. Then I added speed of escalator. How long escalator and Nicole were traveling? They were traveling for 30 seconds. To do what? To reach the ground floor from the top floor. Right. So second equation. Let's come to the second equation. Write it there itself. In the second one, it says that if she tripled her speed. Now listen, there is already a speed. Author is saying that, hey, why don't you triple this, man? All right, okay. Triple this speed means Nicole's speed will be 3 times of 25 by 30. That is what you mean by tripling the speed. Then should have taken only 18 seconds to do this job. All right. Escalator is also going in the same direction. This is the effective speed. Nicole's speed plus escalator speed is the effective speed. How much time they're taking? 18 seconds. So what is this? Each one of them is equal to number of visible steps. Already each one of them is equal to number of visible steps. So therefore, if you are reading this question, this is what I expect you to write, right? This is what I expect you to write. After reading this question, this is what is expected to be written. Direct. This is the thing there. You write there, simplify it, you get the value of E. Once you get the value of E, rest everything can be figured out. All right, let's now go to the solving portion of it. Let's quickly go to the solving portion. Right. I hope everybody should be clear with this. All of you must be clear with what I'm saying. Let's go to the solving of this. Okay. Yeah. So this is nothing but 5 by 6. 5 by 6 plus E. Then this I can cancel 6 3 times, 6 5 times. 5 is also equal to 3 times of 5 by 6. This is 3 10 times, which now becomes 5 divided by 2 plus E times of, right? After resolving this, let's quickly resolve 3 and 5e. Therefore, you will have 2e on one side, 2e on one side. The other side, you would have 15 by 2 minus 25 by 6, right? So therefore, that would become 20 by 6. This is 2 one time, therefore this is 2 10 times. Therefore, you are left with 5 by 4, 5 by 3. What is the value of this? E is equal to 5 by 3. So after solving, you get the value of E is equal to escalator speed is nothing but 5 by 3. Fair enough. Now let's go to the question. Find the total number of visible steps on the escalator when it is turned off. Total number of visible steps can be found from here. From here, I can find it. So which numbers I should take? The original numbers I should take. What is the original number? 3 times of 25 by 30. Of course, we could have simplified it, no problem, but that's a number. Plus E, I'm writing it for E. What is the value of E? 5 by 3. For this E, I'm substituting 5 by 3 times of how much? 18. Times of how much? 18. This becomes the number of visible steps. Either I can use this box or I can use this box. Any of the boxes is fine. One of the boxes is fine. So, all right, therefore, this is 5 times, this is 6 times, this is 3, 2 times. Therefore, you are saying that 5 by 2 into 18 plus 5 by 3 into 18. So let's add them together quickly. All right, therefore, this is 45. This is 30. 30 plus 45, which is nothing but 75. That is the answer to the first part. Okay, second part, why don't you find out? Why don't you find out? Put it in the chat. Why don't you find out the answer for the second part? Put this quickly, put this. Put the answer in the chat. Second question. Use the answer for the first question. Use that. Use that information, then do. Quick, guys. Quick, quick. Other than Gaurav, anybody else? Why it's taking time? So what is that it's saying? If Nicole stood still on the escalator, only the escalator was in motion, what would be the time taken by her to reach the ground floor from the first floor? How many steps has to be taken? 75. We already know this. 75 steps has to be taken. Okay, that is the steps to be covered. 75 steps. So only escalator will move. What is the speed of the escalator? It is here. Speed of the escalator. We already found it. Therefore, I said that everything is there. Just apply it. What is the speed of the escalator? 5 by 3. Speed of the escalator is 5 by 3. Done. Simplify it. You got the answer. 5 15 times. Right? 15 into 3, 45 seconds. All right. It will take 45 seconds. Simple. So everything was right in front of us. Therefore, I said that hey, two numbers are just visible. One hand 75 is visible. On the other hand, 5 by 3 is visible. Just divide them. You will get the answer. So because the time is nothing but what? Distance divided by speed. What is distance? 75 steps. What is speed? Escalator speed. Why this time only escalator is moving? Because Nisha doesn't want, Nicole doesn't want to do anything. Nicole wants to stand still on it. Hey, is this making sense, everybody? Is this making sense to you? Clear? Clear, Stuti? Is this clear? Kristen, clear? Is this making sense? Yeah. Okay. All right. Hmm. You answer this, guys. All of you answer this. Quickly write this, then okay, I will do this. Next is cat question, right? So you do that, right? And the next is cat question. I will give one more practice. Smriti walked down a descending escalator from the first floor to the ground floor in 16 seconds. Had the escalator been stationary, he would have taken 36 seconds. If Smriti's speed is taken as S and the escalator speed is taken as E, what can be concluded regarding S and E? All right, let's take a quick understanding of this. Smriti walked down a descending escalator. She was walking down, she is also walking down, escalator is also coming down. I'm hoping that you are understanding the language very clear there. Okay, and to the ground floor, first floor to the ground floor. In how much time? 16 seconds. Fair enough. So therefore, you are saying that Smriti's speed plus escalator speed 16 seconds, they cover the distance. Okay. Had the escalator been stationary, if the escalator is stationary, escalator is stopped, power went off, escalator is stopped, Smriti has to cover the entire distance. Therefore, the same distance, n is the total number of visible steps. You can also write it as Smriti alone is doing because escalator is not helping. She would have taken 36 seconds to do this. Fair enough. Therefore, yes into what? 36. Because Smriti alone, no escalator. Escalator is not there because it's given escalator has been stationary. If the escalator been stationary, then Smriti alone walks. Done. We get the relationship between S and E from here. Let's resolve it. What is the relationship therefore? You say that this is 4 9 times. This is 4 times. From here, you say that 4E and 4E is also equal to 5. 4E is also equal to 5s. Fair enough. So if I write E is equal to 5 by 4s. Or if from here, if I want to write yes, then S is equal to 4 by 5E. In other words, S is equal to 80% of E if you want in percentage. Why percentage? Because answer options are in percentage. We think the way answers are given. That's it, right? Okay. So therefore, here if you're writing it, E is equal to 125% of yes. All right. Yeah. What is the answer therefore, guys? What is the answer? Can I know the answer? What answer I should mark? Should I mark A? Should I mark B? Should I mark C? Should I mark D? What do you suggest me to mark now? What do you suggest me to mark? Given these data is right in front of you, what should I mark as the answer option? Tell me what I should mark. Quick, what I should mark as an answer. That's right, Gaurav. Yeah. Okay. So you will mark answer as S is already, see, S is equal to 80%. I can't say that S is 100% of E. It is 80% of E. A is ruled out. Second one, E is less than 125%. No, E is exactly 125%. B is out. Okay. S is 70 greater than 75%. Fits in because S is 80%. As 80% is greater than 75%. This fits. Therefore, this fits. Among the choices, C fits better. Right? I can't say that none of them fits. C fits. Or when I go for none of these, I go for none of these provided choices which came before does not fit the scheme. Already choice C is fitting the scheme. Since it is fitting the scheme, I don't have to go for D. I go for D provided none of them which came before that fits that particular scheme, right? Okay. Is it making sense? Is it making sense? Everyone making sense what I'm saying? Clear? Clear? Got hang of this? Right. Good. Okay. Here is the cat question. Here is the cat question. Try it. I'll give 1 minute. We did something similar already. Try this. I'll give 1.5 minutes. Okay, all right. I give close to 1.5 minutes. I think you should have. If I give a little more time, you will close it, no doubt. But then do it with me now. Shama and S and V, let me call it as S and V. S and V walk up an escalator. Escalator is also going up, and these two people are also going up. Everyone is going up. The escalator moves at a constant speed. S takes 3 steps for every 2 steps of the other person. Fine. Let me define it. There is S here, there is V here, and there is escalator here. By the time Shama takes 3 steps, V takes 2 steps. All right. Let's say this. These are the speeds. I'm writing the speed here. By the time one person takes 3, the other person takes 2. What about the escalator? Assume that in the same time escalator takes E steps. I don't know how many steps. Let me write it as E steps there. Then given, Shama gets to the top of the escalator after having taken 25 steps. Fair enough. So therefore, do I know the time taken? Now listen to me. In the given time, say that the time is per second. Per second, they are taking these many steps. Let's assume per second. Right? Shama takes 25 steps to reach to the top. At the rate of what? At the rate of 3 steps per second. Therefore, time taken by Shama is 25 divided by 3. This is the time taken by Shama. Why? V takes only 20 steps to reach the top. All right. Therefore, time taken by V is he took 20 steps at the rate of what? 2 steps per second. Therefore, you say that this is 20 divided by 2. This is the time taken by V. Okay, now let's understand that. Did both of them have to cover the same distance to go from one floor to the other floor? Of course, yes. It is not that one fellow will go more, one fellow will go less, because distance between the two floors is constant. There is no doubt about it, right? So therefore, that remains constant. Let us write, therefore, from Shama's perspective, the number of visible steps, how does it look like? So Shama was taking 3 steps per second, and then Escalator was taking E steps per second. How much time? The first one, how much time? Time is 25 by 3. Okay, 25 divided by 3. This becomes what? Number of visible steps. Hey, what about the second person? The second person, Vyom, was taking 2 steps per second. Escalator was taking E steps per second. How much time? 20 divided by 2. Both are nothing but covering the same distance, because distance between two floors would remain constant, therefore they cover the same distance for sure. Solve it, resolve it. Already you will get the value of E. Let's try that. Therefore, okay, let's try this. So I'm resolving this equation. I'm solving. Let's solve this. I'll multiply it throughout by already, let's say. So this is, let's resolve. 25 4 times. This is 5 times, right? So and then you can cross multiply them. So you can write this as 3 plus E. I will put this 2 on the other side, bring it here. 5 into 2, 10 is also equal to 2 plus E. You can also write it as 3 into, okay, you could have canceled this 2 with this as well. 2 times, that could have been better. And then anyway, that's a simple calculation. Doesn't matter where you what you do. Say this is 5, and therefore this is 3. Take the 3 to the other side. Fair enough. From here you get it as 15, 5e, 3. Therefore you cite 2e is equal to there is some mistake somewhere. What did I do? This is 6. Sorry. This 3 has to be multiplied with these 2. My mistake. Yeah, that is 6. That's what I was wondering. Yeah, okay. So let's rewrite. Therefore, this is 6 here. Yeah, do that calculation. This is therefore 5e and 6e, therefore e on one side. 15 minus 12 becomes 3. Therefore, e is nothing but 2. So you got the value of e is equal to 2. So we got this particular value, e is equal to 2. From here, now he's saying that how many, come to the question, how many steps would they have to take to walk up? How many steps they should take to walk up? Fair enough. Use one of those equations to do it. Let's say that, okay, I decided to use this side of the equation. Let's use this master equation. Number of visible steps is 3 plus E times of 25 divided by 3. Right. So what is the value of E3? Substitute it here. This as 3. Therefore, 6 into 25 divided by 3, which is equal to 50. Number of visible steps, N, is therefore nothing but equal to 50. Simple question, right? So this is what we kind of did before as well. Okay, are you all with me? Making sense? This cat question is clear? Question is clear? Is this making sense? This was a classic cat question on, one of the very classic cat question on escalators. Clear? Can I assume it is clear? Anybody, any doubt? Swati, are you able to follow? You joined in between. Is this clear? Yes, no, say something. Nobody's saying anything. Is it making sense what I'm trying to tell? Are you able to follow? Okay, good. Yeah, right, 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 right. Okay, at the end of the lecture, if the content made sense and the points that I tried to tell you make sense at the end of the lecture, just put the like button there. So that would be encouraging to both of us. First lecture, maybe I'm also getting used to this interface. I'm also learning how to do this. So you will find that I'm pretty cautious. I will generally not be very cautious. I will be very flamboyant with the content. But yes, today I'm extra cautious for a simple reason that the whole interface is looking different to me. It's not my usual sense. Yeah, okay, but it takes only uh, it just takes about one instance to get to understand what it is all about, right? Okay, so there we go. So you like it, and then you can share the link with others as well. Let's go to the next cat question. Let's go to the next cat question. It brings us to another cat. Yeah. Okay, someone is trying to ask me, did you have a class in the afternoon? No, this is the first class for the day. Couldn't do it because of some technical feasibility issues. Who's that, by the way? MEE. That's a code. Can I know the name? Oh, Mohit, all right. Okay. Try this, try this. I'm sure all of you are sitting with pen and paper. Try this. Yeah. A man can walk up a moving up escalator. Listen to me. And this brings to one of the very important concepts. Listen to me. I will do two, three questions based on this and we are done. Okay. Yeah. A man can walk up a moving up escalator in 30 seconds. The same man can walk down this moving up escalator. Escalator is still moving up. So escalator is moving up. So case one, the man was moving up. This is the case one. Case two, the man decided to come down. That is the case two. So therefore, let's understand that in the case one, what is the effective speed? Let me write the effective speed. Effective speed in case one. Effective speed in case one is effective speed and the time taken. Therefore, let's write the time taken. Effective speed in the case one. So man is also moving up. Escalator is also moving up. Therefore, it will become speed of the man. Let me call it as yes, speed of the man plus the speed of the escalator. This becomes the effective speed. All right. Coming to case two. Now let me see. Coming to case two. In the case two, the man decided to come down, but escalator was still going up. Therefore, I will write it as the speed of the man minus speed of the escalator. All right. What is the time taken in the first case? The time taken in the first case is 30 seconds. That's constant. S plus E into 30 is constant, of course. S minus E into 90 will also be constant. Now look, so therefore you can resolve it. We'll get the answer, no doubt about it. Fair enough. So let's solve it first. Let's solve this particular question first. We'll get this as S plus E 30 times. S plus E 30 times is equal to S minus E 90 times. 31 times, 33 times. Therefore, from here you will get the relationship, which is nothing but 2s is also equal to 4e. In other words, s is equal to 2 times of e. The speed of the man was twice the speed of the escalator. Fair enough. Okay, we understood. What is the question? How much time he takes to walk up the escalator? How much time this fellow will take to walk up the escalator? So to understand the time taken to walk up the escalator, what I want, how many steps are there on the escalator? That is nothing but n, number of visible steps on the escalator, divided by speed of the speed of the man. So not the escalator, speed of the man. Why? How much time he takes to walk up the escalator when it is not moving? What is not moving? Escalator is not moving. Speed of the man. Fair enough. Speed of the man is yes only. I don't know that number. Now, what I want to understand the number of visible steps. Fair enough. Let's go here. Let's calculate the number of visible steps from the first one. First or the second doesn't matter because the distance is constant. So let me substitute it there. So I will write E is equal to S by 2. I will write from here E is nothing but S by 2. You may wonder, sir, why you are writing E is S by 2? Why don't you write S as 2E? Simple. I can see it here loud and clear because denominator is S. Try to cancel that S. So if you want to cancel that S, substitute for E. So why you want E here? This E you substitute. So let us write it there. So we are writing it as S plus E value is another S by 2 into 30 is nothing but number of visible steps. This is into 30. Into 30 is number of visible steps. Fair enough. Therefore, let now go in there and figure out 3 by 2 times of 30 is nothing but number of 3 by 2 s times of 30 is number of visible steps, which is nothing but how much. So this is all. This portion is nothing but how much. All this is nothing but 45 s is nothing but the value of n. Substitute 45 s divided by s. What is 45s? Number of steps, because I don't have too much of data to figure out. Therefore, I will write in terms of s only. S and s cancel. Therefore, you will say that time taken is 45 seconds. Time taken is 45 seconds. Now, this brings to one of the very, very important concepts. Lot many questions can be done using this particular concept. Listen to me very carefully on this. Listen to me very, very carefully on this. See, you need to understand that we said when the distance is constant, speed and time are inversely proportional. This concept you listen very carefully. When the distance is constant, speed and time are inversely proportional. Nothing but in case if one of them are in AP, to define an AP, how many terms are required? Minimum three terms. To define any series, minimum three terms are required. Sometimes with three, we'll not be able to find one. That's a different issue. But the minimum three terms are required for it to define an AP out here. Right? Okay. To define an AP here. So let's understand that. So where will that come? Just a second, guys. Okay, yeah. To define the AP, where are three terms here? Now look at this. So look at this. I can write here. Yes, I can write it here. Middle, I will squeeze in another case. I will squeeze in another case here. I will say that the middle is here. All right, I'm just squeezing in another case here. This portion. Watch out only this particular portion, right? So watch out only this particular portion. Let me remove the other portion anyway because it's not required for us. It's not required. Let me remove this. Hmm. Right. So watch out for this. Right? This very important concept. The speeds are in AP. If you observe this column, the speeds are in AP. What is that? S plus E, S, and S minus E. These are the three terms in AP. What is the common difference? Common difference is the there are three terms. One term is S plus E. The second term is S. The third term is S minus E. If you look at this is the term one, first term, second term of the series, third term of the series. Say, what is the common difference here? Minus E. If you come from top to the bottom, it is minus E. But if you go from bottom to the top, you will say that the common difference is E. Add E, you get here. Add another E to this, you get there. Therefore, what you are trying to say here, the speeds are in AP, which means for this I need to find out. And what is this now? This S is nothing but arithmetic mean. If three terms are in AP, the middle term would become arithmetic mean. Therefore, now you have an arithmetic mean. If it is arithmetic mean, we know that speed and time are inversely proportional. Speed and time are inversely proportional. Therefore, what is the inverse of the numbers? If A, B, C are the three terms in AP, then if I write 1 by A, 1 by B, and 1 by C, they would be in HP. We all know that. So therefore, if the speeds are in AP, if the speeds are in AP, then the time will be in harmonic progression. Then the time will be in harmonic progression. See, I'm just talking a little bit of algebra here. If you can digest, you digest it because it gives a lot of time speed. Some time speed questions can be solved much faster provided we understand this concept, right? If the speeds are in AP, then the time will be in HP, harmonic progression. But you want here is what? Yes is nothing but harmonic mean. If that is harmonic mean, the answer required here, you need the time. You need the time here. This time will become the harmonic mean because this is an arithmetic mean. If it is arithmetic mean, the parallel to that will be what? Harmonic mean. Harmonic mean of which two numbers? These two numbers. I need to find the harmonic mean of these two numbers, 30 and 90. How do you find harmonic mean of two numbers? Harmonic mean of two numbers A and B. How do we find? We write this as 2 divided by 1 by A plus 1 by B, which eventually after simplification results in 2AB divided by A plus B. It results in 2AB divided by A plus B. It results in this. Fair enough. So therefore, substitute the same thing out here. Therefore, we'll substitute the same thing out here. Right? Let's come back and substitute the same thing out here. How do we put this here? So therefore, harmonic mean of 30 and 90. I want to find the harmonic mean of 30 and 90, which is nothing but 2 times of A into B, that is 30 into 90, divided by 30 plus 90. 30 plus 90 is 120, right? Therefore, 31 times, this is 34 times, 2 times, 245 times. I would have got the answer directly, given answer. T is nothing but 45 seconds. I would have got the same answer there. See, this concept is important. If the speeds are in AP, then the time taken will be in HP, vice versa. What if you understand that the times are in HP? What if you understand that the time taken are in HP? Fine, then the speeds would be in AP, then the speeds would be automatically in AP, right? So if you are not very clear on this, wait for some geometry classes to get done. You will be able to understand this better. But yeah, basic geometry, basic algebra, so algebra classes. Basic algebra, you understand? No problem. AM, GM, HM, AP, GP, HP. If you just understand that high school syllabus, if you understand, then it is relevant there. Otherwise, just for the time being, remember one key statement. If the speeds are in AP, the time will be in HP. If the time is in AP, the speed will be in HP. Now, what I wanted here was the arithmetic mean. Therefore, arithmetic mean equivalent, equivalent, time equivalent of arithmetic mean in terms of speed. Therefore, time required is nothing but harmonic mean. I simply found the harmonic mean of two questions, two alert given two numbers. Let's do another classic question which came in CAT. Let's do another CAT question based on this concept. Then we will try and put a close to this. Yeah, let's try this. Let's try this question. Let's try this. Just read this. We'll do it together. Right, listen. Okay, so now you understand that the times are in AP. You may wonder, sir, from where you are finding times are in AP. Already in this question, I'm just coming to the direct approach on this. You may find that times are in AP. How do you know times are in AP? Assume that every day he starts at X hours from by his watch. Day one, all at case one. All right, now, so he reached at what time? 1 p.m. Case one, he reached at 1 p.m. X to 1 p.m. X can be anything. You take 7 o'clock, 8 o'clock, 9 o'clock, whatever you want, you take it. All right, yeah. The second case, what happened? He left home at same X, and then he reached at what time? 11 a.m. Then he reached the next time on 11 a.m. Okay. Now, what is he trying to ask me? He says that in the third case, he has to leave at X, but what time he should reach? 12 noon. 12 noon, all at 12 p.m. All right, this is 12 p.m. Now, can I say that these times will be in HL, these times are in AP? You may wonder, sir, how do you know these times are in AP? Take any dummy value of A. Take any dummy value of A. Let me take 8 o'clock to 1 o'clock. All at 1 p.m. Next one is 8 o'clock to 12 o'clock. The other one is 8 o'clock to 11 o'clock. Let's take these same two cases. Case one, this was case two, and this is the required case. This is the required case, right? Yeah. So 8 o'clock to 1 o'clock, all at how many hours? 5 hours. 8 o'clock to 12 o'clock, 4 hours. 8 o'clock to 11 o'clock, 3 hours. So therefore, we know that the moment the numbers you see, one day he reached at 1, the other day he reached at 12, 11, other day he has to reach at 12. We understand that the times are in AP. If the times are in AP, then the speeds will be in harmonic progression. But what is the answer we wanted? We wanted answer for this particular value. This is nothing but what? Arithmetic mean. If it is arithmetic mean, then I just need to find out harmonic mean. Harmonic mean of which two numbers? The first number, what is the speed of the first number? 10 kilometers per hour. You're writing 10 kilometers. Okay, what is the speed in the second case? 15 kilometers per hour. Simply find the harmonic mean of 10 and 15. Let's find out. Therefore, harmonic mean of 10 and 15 is nothing but 2 times of 10 into 15 divided by 10 plus 15, which is nothing but 25. 5 2 times, 5 times, 5 3 times. Therefore, you say that this is nothing but 12 kilometers per hour. Now, this can be done by taking distance constant as well, just like we did in the first lecture. We can do this by taking distance constant as well. But this is how we kind of resolve this particular issue. Okay, is this concept also clear to you? When the speeds are in AP, the time is in HP, or when the time is in HP, the speed is in AP. That's clear to you? Can I assume that it's clear? Whoever is staying back, quickly give me the understanding that it's clear. It's clear. Great. All right. Good, Mohit. Good, Stuti. All right. Yeah. So here we go. So probably I will close this lecture here. You can take this as a homework. I will discuss it at a later stage. So you can take this as a homework. Yeah, you can do this beautiful question as a homework. Very simple question. Very simple question on the same thing. AMHM concept. AMHM concept. So if there is a doubt, I will take it at a later stage. Otherwise, we can do this. Coming to the closure comments quickly. Coming to the closure comments. Yeah, the live mentorship program is available. Use the code to get this off. Yeah. And then there are 3 batches which have commenced. There are 3 new batches which have kind of commenced. And if you are looking at a structured course, you can follow one of these structured courses to start with. Not only this, there are many structured courses which are there. So that's the choice that you have. Yeah, that is pretty much about today. I will see you in tomorrow's lecture at 2 p.m. Tomorrow, I will see you 2 p.m. with DILR classics. And again at 10 p.m. with time, speed, distance. Time, speed, distance, we'll do boats tomorrow. We will talk a little bit about the boats. Boats and streams, effective speed continuation. Escalator was also an effective speed. Tomorrow also we'll be continuing on the effective speed. Book is upstream speed, downstream speed, nothing but effective speed. See you tomorrow at 2. I will catch you there. Bye till then. Good night. Yeah, bye, bye. Bye, Mohit.